Okay, so as per my post, this is something you should already be aware of how to do, is finding the lowest common multiple, the highest common factor from the prime factorisation of two or more numbers. So let's, for example, say we had the numbers 36 and, I don't know, 24. All right, so remember first of all we break it down into two factors. So 36, for example, I could do as 4 times 9. If either of those are prime, then I put a circle around it. They're not. They're both composite numbers because we can break them down even more. 4 breaks down to 2 and 2. Those are both prime, so we circle them. And 9 breaks down into 3 times 3. So we circle both those because they're also prime. So we would finally write 36 equals 2 times 2 times 3 times 3. Generally speaking, a lot of the time you'll see that done in index form, 2 squared times 3 squared. But for when you're finding the highest common factor and lowest common multiple, this version is actually a little bit easier to use. Right, so let's do the same with 24. So it doesn't matter which two I use, I'm going to use 3 and 8. 3 is prime. 8 breaks down into 2 times 4, and 2 is prime. And 4 breaks down to 2 times 2, both of those being prime. So 24 equals 2 times 2 times 2 times 3, or again in index form 2 cubed times 8. It would not matter if I started off with the 24 breaking down into 2 times 12 or 4 times 6. Eventually I will get down to this because that is the kind of one of the fundamental rules, is that every number has a unique prime factorisation. Right, so that's just the recap of that. So let's think about how to use that prime factorisation. So as you might remember, the easiest way to do this is to draw a Venn diagram. Right. And here we would have, for example, the factors of 24. Here we'd have the factors of 36. So again, with Venn diagrams, the easiest thing to do is to fill in the intersection to begin with. Well, in both of these, we've got a 2. In fact, we've got 2 of them. So they both go in the intersection. And we've got a 3 in both of them as well. All right. What's left over in 24? Well, that is 2. And left over in 36 is a 3. So that is our completed Venn diagram. And if you remember, to find the highest common factor, so remember what that means. The highest common factor is the highest number that fits into both of them exactly. Well, we get that from the intersection. So the highest common factor would be 2 times 2 times 3, which would be 12. And the lowest common multiple, if you like, is all the numbers in the union. So I'm using those vocabulary from sets you need to remember. So it's all of these numbers multiplied together. So it'd be 2 times 2 times 2 times 3 times 3, which is 72. Another use for the prime factorisation is because it helps us to work out like the number of factors and whether or not factors are factors of another number without the division. So straight away with 84, I know that 2's a factor. I would know that anyway. I know 3's a factor. I know 7's a factor. I know that 4's a factor. I know that 6 is a factor. I know 14 is a factor. I know 6 is a factor. I know 42 is a factor, 2 times 3 times 7. So I can actually think about what kind of how many factors there are in total, and also kind of what factors there are. So for this one, I start listing them in some sort of way. Well, 2 is a factor, 3 and 7, they're all factors. Well, I've got 2 times 2 would be a factor, 2 times 3, and 2 times 7, and 3 times 7. And I'm thinking about all the different combinations, basically. I've got 2 times 2 times 3, 2 times 2 times 7, and so on. All right, until I can list all the factors by basically finding the different combinations of those 4 numbers. And that's something you do. So these questions vary. You might just have to find the highest common factor and lowest common multiple. You might have to look at the factors and kind of work backwards. You might be told what the highest common factor and lowest common multiple is, and then maybe draw the Venn diagram and kind of do that in reverse. But it's all going back to the basic skills you would have learned in year 7 and year 8. So use those and see how you get on with the questions today.